So that theta prime, that's what refers to the reference angle. That's a symbol that's used for that. Okay. For example, if we've got, actually I want to make one up here first. Okay, let's go to part B first. Okay. Negative 137 degrees. Now think about this. In which quadrant, now then think before you say something, would negative 137 degrees be? Yeah. Yes, very good. Why?
This is negative.
Okay, if it's negative, then it's going in this direction 137 degrees, right? So that's negative 137 degrees. We want the reference angle. And as I said with that definition, the reference angle is always created with the x-axis. So here's the x-axis. That will be theta prime right there. That's the reference angle. Okay? How could we find what that angle is? Okay?
130 or 180 minus 137.
Exactly.
Make it negative, correct?
Well, actually, no. It's always an acute angle. So it doesn't matter if that's negative there. It's the acute angle, so it's got to cause it. So we are going to take, if you look at that, if you go halfway around, that's 180 degrees, right? So we're going almost halfway around. That's just not quite. So you take 180 minus 137. If you do that, what do you get? 43. So the reference angle would be 43 degrees. Okay? Yeah.
Why is it not negative?
By definition, a reference angle is the acute angle created with the x-axis. An acute angle is between 0 and 90. Okay, so it's all definition.
Is there ever an instance where it would be negative?
No. Nope. Again, but the definition of it is an acute angle, therefore a reference angle will always be positive. Always. Always, always, always. How about this 58 degrees? Where would 58 degrees be? Which quadrant? Quadrant 1. That'd be here. 58 degrees. So what would the reference angle be?
180 minus.
90. Put some things together and think. What is a reference angle? It's an acute angle created with the x-axis. It is 58. Yeah, sometimes an angle is its own reference angle. The acute angle created with the x-axis in this case is 58 degrees. So that would be 58 degrees. If the angle that's given is already acute, then that's its own reference angle.
So if it was, even if it was like negative 13, would that be
It will be what?
the reference angle?
What would?
13.
13, yes. So I just want to make sure you wouldn't, I was hoping you weren't leading to negative 13. Yes, but you're exactly right. If it was negative 13 degrees, the reference angle would be 13 degrees. That's the angle that we create with the x-axis. Okay? Now, if we're in terms of radians, we've got some options. Because sometimes you're given these angles in radians. How do you think? Well, first of all, here, we're about to do this whole unit circle thing. Can you tell me where 3 pi over 4 is? What quadrant? Why 4, Josh? Ah, okay. That means that we're breaking something into fourths. It's like 3/4 of pi. Keep going. Yeah.
Would be the second quadrant.
It would be the second quadrant. Why? You know
3
what?
over 4 is equal to 75.
Okay, as in 75 degrees. Okay, now,
And I made
3 over 4 is 0.75.
Yeah.
Now, hear me out on this. Pi radians is how many degrees? 180. This is 3/4 of that. So it's 3/4 of this 180, which would mean it's right there. Now, I'm just curious, because I would think that there's enough people here that at least one of you would have said, I think I would do this differently. What would you do, Morgan?
I don't know.
Okay, but just differently.
Yeah.
Okay, I just want to guess what she said. Yeah,
Are you alluding to converting it into degrees?
sure. What you could do is convert that over to degrees. You're used to working with degrees, so you could convert it to degrees. Subtract, in this case, from 180. And then now, here's the thing though, if this is given in terms of radians, your answer needs to be in terms of radians. Okay? So convert this over to degrees, subtract that from 180, and then convert that back to radians. You could do that. The other thing you could do is here, instead of subtracting from 180 degrees, what is the radian equivalent of 180 degrees? I actually said a little bit earlier. Pi. So what I could do is just take pi minus 3 pi over 4. We've got fractions, right? This is pi over 1. So let's change that to 4 pi over 4, and that would give us pi over 4. Some people look at that and say, no, I want to use fractions as little as possible. I'm going to convert this. And that is absolutely fine. Right? No judgments here. Okay? Mm-hmm.
And that, what are you going to 3 from?
What's that?
What are you going to 3 from?
I took 4 pi over 4 minus 3 pi over 4. So 4 minus 3, 1. Mm-hmm.
What do you mean converting it back to degrees?
So if you convert this, this is 135 degrees. Okay? So you take 180 minus 135. That's 45. Take that 45, that's in degrees. So take that and convert it back to radians. It's a lot of extra work. But some people would rather do that because some people are so frightened by fractions that they would rather just convert it over to degrees, subtract it, and then convert it back over. Yes, it is like 3 extra steps. I choose that, but that's just me. Yes?
So how do you know like where to put the angle? Like,
I think you'll have a little bit better understanding of that after we go through this unit circle. Okay, and this angle in particular, actually 3, 5, or 4 on this circle. Okay, so I'm not ignoring your questions. It will be answered. Okay, how about 7? Where did I get 7? Now that's not 7 pi, that's just 7. Pi is halfway around, right? So 2 pi will be all the way around. Now, pi itself, what's the numeric value of pi? You've been taught this for a very long time. 3.14, and a whole bunch of other stuff, right? So halfway around is 3.14. If you go all the way around, that would be what? 6.28. So this is just a little bit past that. What happens here is you go all the way around, that's 2 pi. You go a little bit further. That would be 7 radians. The angle that that is creating with the x-axis, well, if we rotate it around, why don't we subtract 2 pi from 7 to see what we have left over here? And I do mean subtract 2 pi. As in take your calculator and take 7 minus 2 pi. If you want to go 7 minus 6.28, you can do that. Ryan, what's that give you?
0.716.
Okay, so we'll call it 0.72. So this angle right there will be 0.72 radians. Okay? We good? All right. Here we go. Let's just go ahead and start filling this in. This used to be my SLO. We don't have to do SLO this year. This used to be my SLO. Maybe look right, to be quite honest. I don't say that bragging. I say that because you'll see why. What I would do is, I'm sure you've done an SLO before, where you take like a test or something like that, and then later you take it again, see how much you improved. Well, I would give you a circle with me, my SLO. And I get a whole bunch of 0s and 2s and maybe 8s at the most out of 26. But then at the end of all this, everybody gets like perfect score. Most people get like perfect score. You don't, you just miscount them. So it's like you learn a lot. All right. What we're going to do is you see those little markings on that paper. We're going to go through and label each angle in both degrees and radians. And we're also going to go through and list what the coordinates are. Now, I will tell you this. If you there's going to be a quiz where you're given one of these on Friday. That'll be a 16-point quiz. Okay? What you will do is you'll put your name on there and you'll fill it all in. Everything we're about to fill in right now, that's what you're going to fill in. When you look at this, it's going to be quite overwhelming. Because for each of those 16 points, hence the 16-point quiz, you have to know all that stuff. I'm going to take an approach, which hopefully will be an approach that will allow you to think through these things and not have to memorize basically 48 pieces of information. Let's start with the angle that is here. What angle is that in degrees? Right here. What's that? A little louder. One more. A little louder.
45.
45. No, I'm talking about this angle right here. 0. So that angle right there is 0 degrees. If we go all the way around, then that's how many degrees? 360. Okay. So halfway around is how many degrees? 180. So that's 180 degrees. Make sure you copy this down correctly.
Can you write the 360 underneath?
Yes. Yep. Yeah, in fact, there's a little space there for that. Half of that 180 is what? 90. So it's 90 degrees. Okay? So, check this out here. If we went to 90 here, 180 here, what would this be? 270. So that's 270. And all the way around is 360. Okay? Now let's go to this angle that's in the middle. That's halfway through there, right? So it's half of that 90 degrees. Half 90 is 45 degrees. This is 45 degrees. Okay, now here's what I'm going to be doing this a lot. If you take your fingers, maybe put your thumb right there. Another finger, I don't care which one. There at the 45 degrees. And just start rotating that around. There's 45 degrees, add another 45, that's 90. Add another 45, so that would be this one right here in the middle, 135. Add another 35, that's 180. Add another 35, that will be what down here? 225. Add another 45, you're at 270. Add another 45, so this one down here in the middle, 315. And then all the way around, if you add another 45 there, you get 360. You remember getting to the unit circle last year? Yes? Yeah, that's what I was afraid of, yeah, okay. Do you remember what this angle is? 30. So this angle right here is 30 degrees. And the increment from there to there, again, if you use your fingers here, there, that's 30 degrees, so the next one over is that one right there, as in this one right up here. So if this is 30, this will be 60. Mm-hmm.
What about in correlation to 30, 60, 90 at triangle? Okay.
That's where we get the coordinates. Yep.
Completely blank.
That's where we get the coordinates. Yep. So you go 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and then 360. Take a second there and make sure you have all this accurate. A few years ago, we do weekly unit circle quizzes that'll start next week. And I had a student that like 6 quizzes in. I finally talked to the student and said, what is going on here? You're still having some issues with this. I want to try to figure out why. And I finally looked at her unit circle, and she had some things wrong on that paper that's drawn right now. We completely messed up all those, so make sure you have this right. Now let's go to radians. And again, I'm going to take an approach with this that hopefully will make it easier for you to remember how this goes through. How many radians is this right here at 0 degrees? 0. So that'd be 0 radians. The other line that's there, it doesn't have a degree sign, that's where we put this stuff. All the way around is how many radians? 2 pi. Let's start working with that. So if all the way around is 2 pi, half of the way around will be half of 2 pi, which is pi. Half of that, this is 1 pi, so this would be what? Pi, 1/2 pi, which we call pi over 2. So up here will be pi over 2. Now, I'm going to do this game again, right? I'm going to put my, like, maybe thumb and pinky on those 2 angles there. So I've got, that's pi over 2, which if I flip over, that's 2 pi over 2, which is 1 pi. So like here, this is pi over 2, 2 pi over 2. So down there at 270 degrees would be 3 pi over 2. Which would be followed by 4 pi over 2, which is 2 pi. That falls in place. So if this is pi over 2, what's the one in the middle here, which would be half of that? What's half of a half? Pi over 4, exactly. So this is pi over 4. And I'm going to count that out. So this is pi over 4. This will be 2 pi over 4, which is pi over 2. So over here is 3 pi over 4. And Nev, that's the one I was talking about earlier when you're asking about, well, how do you know where that is? Well, it happened to be an angle that was on the circle. But do you see how that falls into place there?
Yeah.
So that's 3 pi over 4. This is 4 pi over 4, which is pi. So down here in the middle must be 5 pi over 4. Down there will be 6 pi over 4, which is 3 pi over 2. And then over here at 315 would be what?
7 pi.
Very good, 7 pi over 4. And then finish it off with there's 8 pi over 4, which again is 2. Sure. Now, 30 degrees. And I've talked about this before. 30 is what fraction of 180? 1/6, right? So 30 degrees is pi over 6. So this is pi over 6. Again, you can use your fingers here. This will be 2 pi over 6. We're not going to list it as 2 pi over 6. What is 2 pi over 6? Pi over 3. This will be pi over 3. Okay, so 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which is 2 pi over 3. Down here is 5 pi over 6. Followed by 6 pi over 6. That's pi. Now let's just know we're on the right track. Down here would be 7 pi over 6. This would be 8 pi over 6, which is 4 pi over 3. Then we have 9 pi over 6. That's 3 pi over 2. 10 pi over 6, which is 5 pi over 3. And finally, 11 pi over 6. Okay? So those are the angles. You don't have to write this down because you already know this by heart. Okay. One of the definitions for the sine of an angle on the definition of the sine angle is the y value on the unit circle. Is the y value on the unit circle. If you plug in your calculator 30 degrees, go ahead and do that. Plug in sine of 30 degrees. What do you get? 0.5, which is 1/2. That means that the y coordinates on the unit circle at 30 degrees is 1/2. Now, we could prove that with this. The sine of 30 is opposite over hypotenuse, so that's 1/2, right? The cosine of 30 degrees would be radical 3/2, which you can plug that in your calculator. Radical 3/2 is the equivalent of 0.8660. If you plug in cosine of 30, you should see 0.8660 because that's equal to radical 3/2. So the x coordinate here is radical 3/2. Okay? Now here's the thing. Look at 30 degrees, then look at 60 degrees. The sine of 60 degrees is radical 3/2, and the cosine of 60 degrees is 1/2. Isn't that just those flipped? So up here at pi/3, this is the coordinate 1/2 radical 3/2. Okay? The 45 degree, the sine will be opposite over hypotenuse. So that's 1/radical 2. Well, that rationalizes to radical 2/2. So the sine and the cosine of 45 degrees are actually the same because the x and the y values are the same. If you plug in your calculator sine of 45, then plug in your calculator cosine of 45, you're going to get the exact same thing for both of them, and that should be 0.7071. Because if you take radical 2 and divide it by 2, you will get 0.7071. So the x and the y coordinates are both radical 2/2 for the 45 degree angle. That also, if you think about it, makes sense because that 45 degree angle is that like perfectly dividing up these first quadrant. All the x and y values are the same. Now, one little minor detail I kind of left out here. The reason that it's called a unit circle is because the radius of this circle is 1 unit. That's actually slightly important here because that tells you that this coordinate over here is what? Is what? Not 0, 1, 1, 0. This would be the coordinate 1, 0. Up here would be the coordinate 0, 1. To the left, -1, 0. And then down there, 0, -1. Once we have that information, you should be able to fill in the rest of that circle. Take a look at that. No, and we'll do this together. I'm not saying do that right now, but do you see what I mean there? Take a look over here at 2 pi/3. This is the same distance away from that axis as this point is. It's just that we went left instead of to the right. So what would the coordinate of that point be? -1/2. And what's the y coordinate?
Square root 3/2.
Square root 3/2. And this is why I say you should be able to fill in the rest of these. That coordinate in the middle is the same as this coordinate in the middle. It's just the x value is negative. So that's negative radical 2/2, radical 2/2. And at 5 pi/6 is the same as pi/6. Notice how the pi/6s, they match up there because they have a reference angle pi/6. But that would be negative radical 3/2, positive 1/2. Down below here, what would the coordinate for 7 pi/6 be? Josh?
Negative radical 3/2 and -1/2.
Perfect. Negative radical 3/2, -1/2. followed by negative radical 2 over 2, negative radical 2 over 2. And for those of you who are thinking to yourself, there's no way we remember all this, shame on you. This would be negative 1/2, negative radical 3 over 2. By the way, if it's any comfort, every single motion that you're thinking right now as far as unit circle is concerned has been shared by students of many years past, and they all survived. All right, you too will survive. At first I was afraid. I was petrified. Fast forward, I will survive. This is radical 2 over 2, negative radical 2. So over here in the fourth quadrant, remember we went around that whole all students take calculus thing?
Yeah.
We're using that. As in down here in the fourth quadrant, the x value is positive, the y value is negative. So this last one would be radical 3 over 2, negative 1/2. There you have it. It's not even Christmas yet, but I'm giving you this gift. So on Friday, you will be given a blank one of these. You'll fill it in. Seems impossible not this Friday.
I think I'd take a car.
What's that?
I think I'd rather a car.
Oh, well, here's the thing, that car dies eventually. The unit circle will be here forever. It's the gift that keeps on giving. You're welcome. Ungrateful little. What's that? Now, everybody have that copy. All right. Oh, this is being recorded. So, the unit circle. So the unit circle is defined, or is used to define these values. Remember we talked about the sine of an angle being the y value over the r value. Well, the r value for a unit circle is 1. So to find the sine of an angle, for example, if I wanted to find the sine of 3 pi over 4, then I would say, okay, the sine is the y value. What is the y value at 3 pi over 4? And that is radical 2 over 2. Therefore, the sine of 3 pi over 4 is radical 2 over 2. And then you'll start just flying right through and snapping your fingers just like that. So let's use that unit circle to find some of these values. Starting next week, you'll start to have quizzes that look just like this, 10 of those. Let's start with the sine of pi over 3. Okay? On your unit circle, find pi over 3. Stare at it as if it's your best friend, unless you're fighting with your best friend. What quadrant is pi over 3? Quadrant 1. Lauren, do me a favor. Can you tell me the coordinates at pi over 3, both the x and y coordinate?
1/2 and 3, radical 3 over 2.
Good. The sine of an angle is which value, the x or the y? It's the y. Therefore, the sine of pi over 3 is radical 3 over 2. That's all it's doing. So the cosine of 3 pi over 4. Find 3 pi over 4. Delaney, what's the coordinate of 3 pi over 4? The whole coordinate, the x and the y coordinate. And yes, it's in quadrant 2, yes. Negative radical 2 over 2, radical 2 over 2. Now, the cosine is which one, the x or the y? That's the x. What is the x value? Savannah?
Negative radical 2 over 2.
So the answer is negative radical 2 over 2. Okay? Now, tangent is a little bit different. Let's find the tangent of 11 pi over 6. Okay? Ryan, what is the coordinate at 11 pi over 6? And then take your time there. As she's looking for this, you know, this is like brand new stuff. And I think each of the people that I've asked, where is that angle? You took a little bit of time because you're kind of going through that circle and figuring out. One quick way for that is, 11/6 is almost 12/6, right? And 12/6 would be 2. So this is almost 2 pi, as in all the way around. Almost, right? It's that one just before, so that's just kind of thinking of the track. All right, right. What's the coordinate here?
Radical 3/2, -1.
Yes. What is, now you see why I told you the history of this one. See, everything I do in here is for a reason. What's the ratio for tangent? Y over x. What's the southeastern Scandinavian word? Yes. Y over x. So we're going to put the y value over the x value. Now that's all kind of ugly. We don't like fractions and fractions. But what happens with that fraction actually? The 2's cancel. That's happy. So that would be -1 over radical 3. And I do want you to rationalize here. So after we rationalize, what would that be? Negative radical 3 over 3. We doing all right? Okay. Now, what I'm showing you right here, this will not be on this week's unit circle quiz. That's next week. Don't worry about that. All right, this week's is just labeling the unit circle. Okay. 7 pi over 6. Okay. 7 pi over 6. Andrew, what's the, well, actually, you know what? Let's just jump straight to it. Look at 7 pi over 6. Find it, enjoy it, smile at it, be nice to it. The sign is which value, the x or the y? The y. Okay, so Andrew, what is the y value, the y coordinate at 7 pi over 6? -1/2. So your answer? -1/2. My goal for each and every single one of you is that you'll be able to do exactly what I just did, as in just write down the answer. That's why we do the unit circle. We just go straight to the answer. All right, questions? We all good? You excited? You finally reached that day? Yes? No, this means yes. This means no. I don't think you understand. Okay. All right, there's your sign.
Oh.
So there's quite a few here, but think about those last 4. Once you get this down, you can fly right. Yes, sir. One second. What's that?
When you were saying what sine, cosine, tangent were, I wanted to write it down.
Okay.